Myself, Tarun, studying in Student National College of Engineering, SCSCAI. Today's topic is recommender systems. Welcome to our explanation of recommender systems. We'll discuss the core concepts, different types, and the power of algorithms in the personalized recommendations. Recommender systems in artificial intelligence and machine learning are algorithms designed to suggest relevant items to users based on their preferences, behaviors, or interactions. These systems are uh, widely used in domains like e-commerce, streaming platforms, and social networks to enhance user experience and engagement. There are different types of recommender systems: content-based filtering, collaborative filtering, hybrid methods, matrix factorization, deep learning-based recommendations, context-aware recommenders. First one, content-based filtering. Recommends items similar to those a user has interacted with based on item attributes. Example, suggesting movies with similar genres or actors. In the collaborative filtering, leverages user behavior data to find patterns of similarity between users or items. There are two types: user based and item based. In user based, find users with similar preferences. In item based, finds often co-selected by users. The power of recommender systems. Personalized experience. Recommender systems tailor suggestions to individual preferences, improving user engagement and satisfaction. Increased revenue. By promoting relevant items, businesses can boost sales and drive revenue growth. Enhanced discoverability. Users can discover new products, services, or content they might otherwise miss. Types of recommender systems: content-based, collaborative, filtering, hybrid. In content-based recommends item similar to those a user has liked in the past based on content features. Collaborative filtering uses the preferences of similar users to recommend items, leveraging collective wisdom. In hybrid, combines content-based and collaborative filtering approaches for a more comprehensive recommendation. Machine learning powers clustering, matrix factorization, deep learning. In the clustering, groups users or items with similar preferences, enabling tailored recommendations. Matrix factorization decomposes user item interaction matrices to predict preferences and generate recommendations. Deep learning leverages neural networks for complex pattern recognition and personalized recommendations. Data, the foundation of recommendations. Data collection. Gathering user interactions, item information, and context data is essential. Pre-processing. Cleaning, transforming, and preparing data for efficient analysis and model training. Future engineering. Creating meaningful features that capture user preferences and item attributes. Collaborative filtering, the power of community. User based and item based. Recommends item based on the preferences of users with similar tastes. In the item based, finds items similar to those a user has liked in the past based on other users' preferences. The matrix factorization, a machine learning techniques that reduces the dimensionality of all user item interaction matrix to predict missing values. Example, latent factors like user preferences. The deep learning based recommenders employ neural networks to model complex relationships and extract features from raw data. Example, user profiles, item metadata, or images. Context aware recommenders takes contextual information like time, location, or device into account to personalize recommendations. There are AML techniques used in recommender systems. Natural language processing used to analyze text-based data like reviews, descriptions or search queries. Uh, Graph neural networks capture relationships between users and item in a complex interaction networks. Reinforcement learning optimize long-term user satisfaction by learning from feedback over time. There are some challenges in recommender system. Cold start problem, difficulty recommending for new users or items with insufficient data. Scalability, handling large data sets with millions of users and items efficiently. Data sparsity, limited user items interactions can reduce prediction accuracy. There are some applications of recommender systems. E-commerce, suggesting products based on browsing or purchase history. Like example, Amazon. Streaming platforms, recommending movies to TV shows or music. Example, Netflix or Spotify. Uh, Social media, personalizing feeds or suggesting friends. Example, Facebook, Instagram. Education, recommending courses or learning paths. Like example, Khan Academy. Healthcare, suggesting treatments or health related content. Recommender systems continue to evolve with advancements in AML, making them more personalized, accurate, and content based filtering, understanding preferences. Future engineering, extracting relevant features from item descriptions, user profiles, and other data sources. Text mining, analyzing text data such as product reviews or user feedback to identify key features and preferences. Hybrid recommender systems, the best of both worlds. Integration, merging content-based and collaborative filtering techniques for a comprehensive approach. Synergy, combining strengths to provide more accurate and diverse recommendations. Enhancement, improving the overall performance uh, and reliability of recommendation systems. Evaluating recommender systems, measuring success. Precision, the proportion of recommended items that are relevant to the user. Recall, the proportion of relevant items that are recommended to the user. F1 score, a harmonic mean of precision and recall, balancing both metrics. The future of recommender systems, trends and innovations. Contextualization, recommending items based on real-time user context, location and time. Explainability, providing transparent explanations for recommendations, fostering user trust and understanding. Privacy, developing ethical and privacy preserving recommender systems that protect user data. Thank you for watching my video. Please like, share and subscribe.